Let's reduce the following fractions into lowest terms. So you'll remember from our last lesson that in order to do this, we need to look for a number that will divide evenly into the numerator and the denominator. Because these are both multiples of 5, so they end in a 0 and a 5, we can divide both of these terms, or both of these numbers, by 5. 10 divided by 5 is 2. 25 divided by 5 is 5. And there is nothing left to divide evenly into 2 and 5, so this answer is complete. Looking at the next question, 18 over 27. They are not multiples of 5. They are both not even numbers, so then we have to look for some other numbers that might divide evenly into the numerator and the denominator. So let's take a look at 3. Does 3 divide evenly into 18? Yes, it does. Does 27 divide into 18? Yes, it does. Does 3 divide evenly into 27? Yes, it does. So let's go ahead and divide both our numerator and our denominator by 3. So 18 divided by 3 is 6, and 27 divided by 3 is 9. Now, this isn't in lowest terms yet because we can find another number that will divide evenly into 6 and 9, and that number is 3 again. So 6 divided by 3 is 3, and that's 2. And 9 divided by 3 is 3. So that leaves us as 2 over 3, which is in lowest terms. If you knew that both 18 and 27 could be divided by 9, you could have done that in one step as well. So if you need to take multiple steps like we did here, you're welcome to do that. If you know what the answer might be, you are welcome to do that in one step. So 18 divided by 9 is 2, and 27 divided by 9 is 3. So you'll get to the same final answer, but with less steps. 65 over 91. So what would this be in lowest terms? Well, again, we need to look for a number that might divide evenly into both the numerator and the denominator. So, well, we know that they're both not multiples of 10. We know that they're both not even numbers. So then we have to work our way up through the ranks. So can I divide it by 3? No. Can I divide it by 4? No. I know I can't divide by 5. What about if I divide it by 6? Will that work? No. What about 7? No. 8? No. 9? No. What about 11? Nope. So sometimes it's going to be difficult for you to look for that number that will divide evenly into both that top and that bottom number. And so you just have to keep working up the numbers in order for you to find one that works. The one that does work is 13. So I can divide both my numerator and my denominator by 13. So that gives me 5 in the numerator and 7 in the denominator. So don't be afraid to go up higher than 12 because sometimes that has to be what has to happen. All right, let's take a look at part D then. So 48 over 64, they're not multiples of 5, but they are both even numbers. So let's start by dividing them by 2. 48 divided by 2 is 24, and 64 divided by 2 is 32. These are still both even numbers, so I'm going to keep dividing them by 2. 24 divided by 2 is 12. 32 divided by 2 is 16. Well, those are still both even numbers, so let's keep dividing by 2's. 12 divided by 2 is 6, and 16 divided by 2 is 8. Those are still even numbers. Let's go ahead and divide those by 2 again. 6 divided by 2 is 3, and 8 divided by 2 is 4. That is finally in lowest terms. So you are welcome to take those steps if you need to, or you may have known that I could have divided both of these by 16 to get to 3 over 4 right away. You could also have divided them by 4, you could divide them by 8, but this is a strategy that always seems to work. All right, so let's move on to fractions and decimals. Well, we know that fractions are just another way of writing division. So therefore, a fraction can be converted to a decimal by carrying out the division. So 3 over 4 is the same as 3 divided by 4, and 3 divided by 4 gives us 0.75. So we're going to go ahead and change all of these fractions into decimal numbers by dividing our numerator by our denominator. So this 5 over 8 is the same as 5 divided by 8. And 5 divided by 8 is 0.625. 4 over 9 is the same as 4 divided by 9. And 4 divided by 9 is 0.4 repeating. So I'm going to place a little dot above that 4 to show that this repeats forever and ever and ever. So this shows that this is a repeating number or a repeating decimal. Three over 6 is the same as 3 divided by 16, and then 3 divided by 16 is 0.1875, and 7 over 12 is the same as 7 divided by 12, and 7 divided by 12 is 0.583, and the 3 repeats forever and ever and ever. So I'm placing a dot over my 3. Well, if we know how to convert a fraction to a decimal, how do we go in reverse? And this is where the concept of place values comes into play. So when we are converting decimals to fractions, we have to know how to read the decimal values appropriately. And by reading our decimal number in a mathematical format, it's easier for us to directly translate that into the fraction. So we can read this as 0.37, but mathematically it's 37 hundredths because we have to look at the place value. And because we read it as 37 hundredths, it gives us a clue about what our denominator has to be. And then from there, we would change this fraction into lowest terms if it's not already in lowest terms already. So I want to change each decimal to a fraction. So in order to do that, I need to look at the place value. So the 8 is in the tenths place value. So this becomes 8 over 10. But 8 over 10 can be reduced. I can divide both of these numbers by 2 to give me 4 over 5. Let's take a look at part B. So I have 0.45, which is the same as saying 45 hundredths, because this 5 is in the hundredths position. So this becomes 45 over 100. And I can divide both of those terms by 5 because they are both multiples of 5 to put it into lowest terms. So it becomes 9 over 20. And that is in lowest terms. Let's take a look at the next one. Our 5 is in the thousandths position. So this becomes 125 over 1,000. And I may want to divide this by a larger number than 5 right away. So in order to put this in lowest terms, why don't we start by dividing that by 25 instead? So 125 divided by 25 is 5. And 1,000 divided by 25 is 40. And from here, I can make this into lowest terms by dividing my numerator and my denominator by 5 again to give me 1 over 8. And the last one, what my place value is my 4 in, that is also in the thousandths position. So this becomes 64 over 1,000. And again, I want to put this into lowest terms. So maybe I want to start by dividing this by 8, because I know that both of these numbers can be divisible by 8. You could start with 2, but I'm going to start with 8 this time. So 64 divided by 8 is 8, and 1,000 divided by 8 is 125. And that is in lowest terms. So now let's just recap how we round to accuracy. So we want to think about what place value we have to round to. So in this number, it's 2.139. I have to round it to the nearest tenth. So that's the 1. And then I look to the right of that. The number beside that is a 3. So I keep that as a 1. So 2.1. For the next one, if I'm rounding to the nearest hundredth, I find the number that's in that hundredth position. I look to the right of that. My 5 is 5, and so I have to round that 5 in my hundredths place value to 6. So it becomes 76 hundredths. To the nearest whole number is to the ones. Again, I look to the right of that. That's a 7, so I have to round this 8 up to a 9. So 219. And lastly, to the nearest tenth, I look to the right, and that's a 6, so I have to round this 9 up to a 10. But when I do that, I have to add 1 to my ones position, so this becomes 43.0. You can choose to write the 0 because it's being asked to round to the nearest tenth, or you could just write it as 43. If you have any questions about this lesson, please reach out to me, send me an email, sign up for a virtual help session, and I will see you in the next lesson.